I'm excited to talk about the most important file in the entire project, DVC-YAML, the engine of a reproducible pipeline. This video focuses on the role of a single DVC-YAML file in orchestrating an end-to-end MLOps pipeline. Additionally, Jinja 2 templates simplify generation and maintenance of DVC-YAML by enumerating transformations in Python code. It generates DVC-YAML using loops and conditional statements. The output is a valid DVC-YAML file that includes all stages and optionally plots. Now let's have a look at how DVC-YAML is generated from this Jinja 2 template. So we loop over each stage and stages, and we add the CMD line, the description line, the frozen line, and the dependencies list under deps, as well as the outs list if there are any outs that should be tracked by DVC. Otherwise, we simply add an empty list at the end. This is how we generate each stage and stages, and the same principle applies for how we add the plots. So let's look at our transformations. Our transformations all follow the same structure. We wanted them to be self-contained and to be typed so that our Hydra config is a structured config. To do this, we made sure that each transformation accepts a data frame and either returns a data frame or none. Like this, we were able to harness our universal step function that can process any transformation. In this case, we're looking at a transformation that adds a column named total mean profit, has its own typed data class, and is atomic. The structure also facilitates partial reruns if a single transformation changes. DVC reruns only the affected stage rather than the entire pipeline. DVC versions everything associated with the stage in DVC-YAML, and Git tracks DVC-YAML itself. We also use MLflow and Hydra to log other crucial parts for each execution. The following example shows how a typical workflow using DVC repro looks like. Only rerun stages that have been modified or that depend on a stage that has been modified. To illustrate this, we're examining DVC-YAML, specifically focusing on the yearly discharge bin stage. We can see it right here where the cursor is, and if we go to the associated YAML file, the config, we can see that the number of bins is set at 5. When the num_bins parameter is set to 5 in pandas qcut, the data is split into the 0th, 20th, 40th, 60th, and 80th, and 100th quantiles. So we plan to change this to 20. So with 20 bins in pandas qcut, basically we're looking at 5% increments, and we have two methods of doing this. So the first method is adding an explicit override here to the cmd command, or we can change it in the YAML file, which we will do in this case. All right, then let's look at the stage, and currently we have it set to number of bins 5. Now let's change that to 20, and let's see what that means. So if we go for DVC repro, we go for a dry run like this, we can see it even more clear, and we can see that there are changes. However, because the stage is cached with the current changes, it's not being rerun. So if we do run it, let's do it. DVC repro, DVC. So this is updating the data version 10. And we are going to run our examples here. And we're going to look at the number of unique values for the yearly discharge bin. So we get 20. That's exactly what we did here. So that's updated. And if we go for DVC status, all pipelines are up to date. That's great for us. And now if we want to go back, we can basically we run DVC repro. Again, it's cached. And we go for status, all up to date. And we can check it now here. And we're back to number of bins 5. That's how easy it is. This video offers insights into how an effectively managed DVC YAML transforms a complex set of ML tasks into a clean, maintainable workflow.